Here we're going to review an example of how to solve a log equation. Now if you notice on the left-hand side of the equation, we have two individual log terms separated by an addition sign. We're allowed to take those two individual terms and combine them into one single log term as long as we multiply what's right here and what's here. So what I mean is we could rewrite this as log to the base x plus 3 of 2x plus 3 times x plus 5 equals 2. And keep in mind, if that original sign right here was subtraction instead of addition, instead of multiplying, we'd be dividing. Okay, now, once you have one single log term on one side of the equation and not the other side of the equation, the only way to get rid of the log is to circle the base and run the race. So when you do that, what happens is the word log drops off and the x plus 3 now becomes the base on the other side of the equation. So what we're left with is 2x plus 3 times x plus 5 equals x plus 3 squared. So the x plus 3 now becomes the base on the other side of the equation. Now from here, all we're doing is we're going to solve algebraically. So on the left-hand side of the equation, we're just going to simply double distribute, leaving us with 2x squared plus 10x plus 3x plus 15. And on the right-hand side of the equation, when something's squared, what it means is that you have two of them. So this really is the same as x plus 3 times x plus 3. So if you were to double distribute that out, you would be left with x squared plus 3x plus 3x plus 9. Okay, so now we're just going to combine our like terms on both sides of the equation. So on the left-hand side, we can combine the 10x and the 3x. So that's going to leave us with 2x squared plus 13x plus 15. And on the right-hand side, we can combine the 3x and 3x, leaving us with x squared plus 6x plus 9. So now we want to move everything to one side of the equation. So we're going to take all of the terms on the right-hand side of the equation, and we're going to subtract them over. So if we take this x squared and subtract it from the 2x squared, that's going to leave us with an x squared. If we take them plus 6x, so we want to subtract it, so if we take the 6x and subtract it from the 13x, it's going to leave us with 7x. And if we take the positive 9 and subtract it from the positive 15, 15 minus 9 is 6, so plus 6 equals 0. And from here, all you have to do is factor. So two numbers that multiply to 6 and add to 7 are 6 and 1. So we'll have x plus 6 and x plus 1. And to finish solving, you would make a t-chart, and you'd wind up with x equals negative 6 and x equals negative 1. Now, what's really important with log equations is you have to remember you are not allowed to have a negative log or a zero log. So let's take a look. Let's start by taking a look at the negative 6. If you take negative 6 and substitute it back into the original equation, if it creates a negative anywhere, it means it's an extraneous root. You cannot use it. So let's start right here, and let's look at if we substituted it into this base. So if we replace the x with a negative 6, well, negative 6 plus 3 is negative 3. It creates a negative. You can't have a negative base. You can't have a negative anywhere with logs. So what we're going to do is we're going to cross that off. Now we're going to take the negative 1 and we're going to substitute that in. And if we substitute it in to, let's see, let's start off with this base again right here. If we substitute it in to the x plus 3, negative 1 plus 3 is positive 2. So that's positive, that's fine. If we substitute it in here, 2 times negative 1 plus 3 is also positive 1. That's fine. Okay, we've already plugged it into the other base of x plus 3, so you don't have to do it again. But if you plug it in here, So negative 1 plus 5, that's positive 4. So again, it's positives. So even though x equals negative 1 is a negative number, it creates positive logs, so we can use it. So our solution set here is just negative 1. Okay, that's your answer.